So let's now have a look at AAS, or atomic absorption spectroscopy, and how it's been used to influence our understanding of the trace elements. So, what is a trace element? Basically, it's an element that's in the environment or an organism. This is particularly talking about an organism in really small quantities. They tend to work in organisms by helping the enzymes do functions. So iron, for example, with hemoglobin, is a trace element. The concentration's really, really low. It's usually between 1 to 100 parts per million. That's a really small amount. So, in other words, before AES was developed in the 1950s, the analytical methods we have weren't sufficient to detect these trace elements. So when scientists first began using AES, they started to use it on soils and organisms. That's when we discovered these trace elements existing in the first place. Now, AES itself was invented in 1954 by a CSIRO scientist called Professor Alan Walsh. It's been used to help demonstrate the necessity and the function of elements. And we do this by knowing, alright, so this is how much we have. If we take some out, this is what happens to the organism, and we can actually measure how much we're taking out and how much we're putting in there. So, because of this, AES itself has had a great impact on our understanding of trace elements. So, in biology and agriculture, they've been really, really important. But in the case of ill health of an organism, we can use AES to detect what trace elements are there and how much are there. Remember, it's a quantitative method. So, when you go to get your blood checked, they're checked using AAS for iron and so forth. If we observe the trace element is deficient, well then we can fix it, we can add more. And this is particularly useful with stuff which we can add through nutrition or through intravenous. It's been a really important thing. We talk about seafood. Seafood tends to bioaccumulate a lot of environmental heavy metals, so it's really good for testing how much of it is in certain organisms. So basically, it's been really, really useful in the fields of agriculture. Now, for example, previously in certain areas in southwestern Australia, that we thought there was quite a lot of cobalt in the soil, and what we thought was good pasture land. But by using AES on the soil, we could work out that there wasn't enough cobalt, which is a micronutrient that is essential for cattle. We could also work out that there was enough molybdenum in certain soils for vegetable crops. It's an important micronutrient for certain vegetable crops. Alright, I hope that made sense. If it didn't, ask any questions in the comments below, and we'll get back to you as quick as we can. Thanks for watching. See you next time. Bye now.